Coming to the first question, two cubes, each of volume 64 centimeter cube, are joined end to end. Find the surface area of resulting cuboid. Now, moving on to solution. He has given that two cubes, each of volume 64 centimeter cube, are joined end to end. So here, we know that a cube has all sides equal, and he has given volume of one of the cube as 64 centimeter cube. If two such type of cubes are combined to form a cuboid, then if we observe in the figure, there will be only change in the length of the cuboid. So, when two cubes are joined, the resultant cuboid will be having length of side plus side of the cube, that is, let it be as x plus x, which is equal to 2x, and breadth will be equal to height, that is equal to, let it be as some x. Now, volume of cube in terms of x, that is side, will be equal to x cube. Therefore, now we can equate x cube is equal to 64, which implies x is equal to 64 whole power 1 by 3, that is equal to 4 centimeters. Therefore, now length of the newly formed cuboid is equal to 2 into x, that is 2 into 4, 8 centimeters, and breadth is equal to x centimeters, that is 4 centimeters, and height h is equal to 4 centimeters. Therefore, we know the volume of cuboid is equal to product of length, base and height, which is equal to, here length is 8 and breadth is 4 and height is 4. Therefore, here 4 times 4 is 16 and 16 times 8 is 128 centimeter cube. That is the answer. Now, moving on to second question. A vessel is in the form of hollow hemisphere mounted by a hollow cylinder. The diameter of hemisphere is 14 centimeters and the total height of the vessel is 13 centimeters. Find the inner surface area of the vessel. Now moving on to the solution. Here, for the vessel, we have an hemisphere mounted by the hollow cylinder. This is represented in the 2D form. And here, we have given that diameter of hemisphere is equal to 14 centimeters. Therefore, now radius of hemisphere will be equal to diameter by 2, that is 14 by 2, which is equal to 7 centimeters. Now, he is asking us to find inner surface area of the vessel. In order to find the inner surface area of the vessel, we need to find the inner surface area of the cylinder and also the inner surface area of the hemisphere. So, in order to find that, let us find the height of cylinder, which is equal to, here total height is given as 13 centimeters minus, from that we need to subtract this height, that is nothing but the radius here, which is equal to 7 centimeters. Therefore, we get the height of the hollow cylinder as 6 centimeters. Now, the internal surface area of sphere, that is hemisphere, is equal to 2 pi r square, which is equal to 2 into 22 by 7 into radius is here 7 centimeter into 7 centimeter, which is equal to, here 7 goes in 7 one time, and 22 times 7 is 154 and 154 times 2 is 308 centimeter square. Now let us also find the surface area of cylinder, which is equal to 2 pi RH, that is 2 into 22 by 7 into 7 times 6, which is equal to, 7 goes in 7 one time, and 2 times 22 is 44, and 44 times 6 is 264 centimeters square. Therefore, the total internal surface area is equal to the surface area of hemisphere, that is 308, plus surface area of cylinder, that is 264, which is equal to 574, that is equal to 572 centimeters square. This is the solution. Now coming to the third question. A toy is in the form of cone of radius 3.5 centimeters mounted on a hemisphere of same radius. The total height of the toy is 15.5 centimeters. Find the total surface area of the toy. Now coming to the solution. Here he has given information that toy is in the form of cone of radius mounted on the hemisphere of same radius. So here the radius of cone and the hemisphere are given by r, which is equal to 3.5 centimeters, and the total height of the toy is given by h is equal to 15.5 centimeters, let it be as capital H, and from this let us find height of only the cone, which is equal to, here from the figure we can say that the height of the only cone can be obtained by subtracting the total height of the toy from the radius of the hemisphere. So that is equal to 15.5 minus 3.5, which is equal to 12 centimeters. Therefore the height of the cone is 12 centimeters as represented. Now he asked us to find the total surface area of the toy. So in order to find the total surface area of the toy, we initially need to find the surface area of the cone as well as the surface area of hemisphere, and then add them to get the total surface area of the toy. So initially let us find the surface area of hemisphere. Let it be represented by S1, which is equal to 2 pi r square, that is equal to 2 times 22 by 7 times r square is here 3.5 into 3.5. So here 35 goes in 3.5 goes in 7 2 times, and 2 goes into 1 time, which is equal to 22 times 3.5 is 77 centimeters square. Therefore we got the surface area of hemisphere as 77 centimeters square. Now let us also find the surface area of cone, which is equal to pi r l, where L is here the slant height. We know that slant height in the cone, when the radius and height is known as, L is equal to square root of r square plus h square, which is equal to square root of r square is 3.5 whole square plus h square is 12 square, that is equal to square root of 3.5 whole square is 12.25 plus 12 square is 144, which is equal to square root of 156.25, which is equal to, therefore here root of 156.25 is 12.5. Now let surface area of cone be S2. Here S2 is equal to pi, that is 22 by 7, into radius is given as 3.5 into 12.5. Here 3.5 goes in 7 2 times, and 2 goes in 22 11 times, and here 11 times 12.5 is 137.5 centimeters square. Now the total surface area of toy is equal to S1 plus S2, which is here 77 plus 137.5, that is equal to 214.5 centimeter square. That is the required answer. Now Let us discuss fourth question. A cubical block of side 7 centimeters is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. Now coming to the solution. Here it is given that a cubical block is surmounted by the hemisphere. So when the cubical block is surmounted by the hemisphere, he is asking what is the maximum diameter of the hemisphere. So here the maximum diameter of the hemisphere will be its side only, side of the cube only. That will be clear from the figure, which is equal to 7 centimeters. Now he is asking what is the surface area. So the total surface area is equal to, the total surface area required can be obtained by adding the surface area of cube and hemisphere, then subtracting it from the surface area of the base of the hemisphere. That gives the required surface area, which is equal to surface area of cube plus surface area of hemisphere minus surface area of base of hemisphere. So here we have side of the cube as 7 centimeters. We know that surface area of cube, let it be as S1, which is equal to 6s square, which is equal to 6 times 7 into 7, that is equal to 6 times 7 times 7 is 294 centimeters square. Similarly, surface area of hemisphere S2 is equal to 2 pi r square, which is equal to 2 times pi value is 22 by 7 into r square. Here is, we have the diameter of hemisphere as 7 centimeters. Therefore the radius will be equal to half times diameter, that is 3.5 centimeters. So here that will be 3.5 into 3.5. 3.5 goes in 7 2 times and 2 goes into 1 time. So now we left with 22 times 3.5, which is equal to 77 centimeters square. And now surface area of base of hemisphere is equal to pi r square, which is equal to 22 by 7 into r square. Here is 3.5 into 3.5. Here 3.5 goes in 7 2 times and 2 goes in 22 11 times. So that is 11 times 3.5 is 38.5 centimeter square. Let it be as S3. Now the required surface area is equal to S1 plus S2 minus S3, which is equal to S1 we have it as 294 plus S2 we have it as 77 minus S3 we have it as 38.5, which is equal to, so that is equal to 294 plus 77 minus 38.5 is 332.5 centimeter square. That is the solution. Now coming to the fifth question. A hemispherical depression is cut out from the one face of cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. Now coming to the solution. Here, the diameter of the hemisphere and the side of the cube are given same, that is L centimeters, and he has also given the, and he has asked us to find the surface area of remaining solid. So here, the surface area of remaining solid is equal to surface area of cube plus, we need this surface area, that is curved surface area of hemisphere minus, we need to eliminate this circular portion, so area of circular portion. Let this be as some S1, let this be as some S2, and this be as S3. Now S1 will be equal to surface area of cube, that is 6 into side square 6L square, and the surface area of hemisphere will be 2 pi r square, which is 2 pi into r square is here half the length of the cube, that is L by 2 whole square, which is equal to pi L square by 2. Finally we left with S3, that is equal to area of the circular portion, which is pi r square, that is pi into L square by 4. Now the surface area required is equal to S1, that is 6L square, plus S2 is pi L square by 2 minus S3 is pi L square by 4, which is equal to 6L square plus pi L square by 2 minus pi L square by 4 is pi L square by 4, which is equal to, let us take L square common here, let us take L square by 4 common here, then we get 6 times 4, that is 24, plus pi value centimeter square. That's the solution. Here, now coming to the sixth question. A medicine capsule is in the form of a cylinder with two hemispheres stuck at each of its ends. The length of the entire capsule is 14 mm and the diameter of capsule is 5 mm. Find its surface area. Now coming to the solution. Here the capsule has been given with the diameter of hemispheres at two ends as with the diameter at two ends as 5 mm. So now the radius of hemisphere r is equal to d by 2, that is 5 by 2, which is equal to 2.5 mm. Now the total length of capsule L is equal to 14 mm given, and now if we see here, we can divide the capsule into three parts, that is two hemispheres and a cylinder. Now for the hemisphere we got the radius as 2.5 mm. Now for the cylinder we have the radius of base as 2.5 centimeters. Let us find the length of cylindrical part, which is equal to 14 minus these two radii of the hemisphere has to be eliminated, that is 2 times 2.5, which is equal to 14 minus 2 times 2.5 is 9 mm. Let this be as some h for the cylinder. Now let us find the surface area of hemisphere, which is equal to 2 pi r square, that is 2 times 22 by 7 into r square here is 2.5 into 2.5, whose value is 275 by 7, which can also be written as, let the pi be as it is, then we get 2 times 2.5 is 5 and 5 times 2.5 is 12.5, that is 12.5 times pi centimeter square. Now let us also find the lateral surface area of cylinder. Let this be as S1 for hemisphere and S2 for the cylinder, that is equal to 2 pi RH, that is equal to 2 times pi, let it be as it is, and radius we have it as 2.5, and the diameter and the height or the length of the cylinder is 9, that is equal to 2 times 2.5 is 5 and 5 times 9 is 45 pi centimeter square. Therefore now we get total surface area is equal to 2 times S1, that is 2 times the surface area of hemispheres, plus S2, that is surface area of cylinder, which is equal to 2 times S1 is 12.5 times pi, plus S2 here is 45 pi, that is equal to 2 times 12.5 is 25 pi plus 45 pi, which is equal to 25 plus 45 is 70 pi, that is equal to 70 times pi value is 22 by 7. Here 7 goes in 70 10 times, and 10 times 22 is 220 centimeter square. That's the solution. Now coming to the 7th question. A tent is in the shape of cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 meters and 4 meters respectively, and the slant height of the top is 2.8 meters, find the area of canvas used for the making of tent. Also find the cost of canvas at the rate of rupees 500 per meter square. So here now coming to a solution. Here a tent is given, which is nothing but the cylinder mounted by a cone. For this, he has given that diameter of the cylindrical part is 4 meters. So here the radius will be equal to half of diameter, that is half of 4 meters, which is equal to 2 meters. And he has given the height of the cylinder, that is equal to 2.1 meters, and the slant height of cone L is equal to 2.8 meters. So let us represent here. It is 2.8 meters. The diameter is 4, so radius will be 2, and the height is given as 2.1 meters. Therefore here total surface area is equal to sum of surface area of this circle and lateral surface area of this circle, the lateral surface area of this cylinder, and the lateral surface area of the cone. So here if we consider the surface area of cone plus the lateral surface area of this cylinder, then we get the total surface area of the tent, that is equal to surface area of cylinder laterally, that might be S1, plus the surface area of cone, that is also laterally, let it be as S2. Now S1 is equal to surface area of cylinder, that is 2 pi RH, which is equal to 2 times 22 by 7 times R, that is 2 times H is here 2.1 meters. Here 7 goes in 2.1 0.3 times, and 2 times 2 is 4 and 4 times 0.3 is 1.2. Therefore we get 22 times 1.2 is 26.4 meter square. Now S2, that is surface area of cone, which we know it as pi RL, where L is the slant height, that is equal to pi value is 22 by 7 and the R value is 2.8 and the R value is 2 and the slant height is 2.8, which is equal to, here 7 goes in 2.8, 0.4 times, and 2 times 0.4 is 0.8 and 22 times 0.8, that is 17.6 centimeter square. So finally we get the required surface area is equal to S1, that is 26.4 plus S2 is equal to 17.6, which is equal to 26.4 plus 17.6 is 44 centimeter square. Now he has given that cost of 1 meter square of canvas tent is rupees 500. Now he is asking the total cost of canvas, which is equal to surface area is 44 into 500, that is equal to 22,000 rupees. Now coming to the 8th question. From the solid cylinder whose height is 2.4 centimeters and diameter 1.4 centimeters, a conical cavity of same height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter square. Now coming to the solution. Here he has given a solid cylinder from which the conical cavity is taken out. For that, the radius of cylinder R is given by half the diameter, that is half of 1.4, which is 0.7 centimeter, and here the height of the cylinder or the cone or same, H is given by 2.4 centimeters. Now he is asking to find the total surface area. So here total surface area can be obtained by the surface area of the cylinder laterally let this be as S1, and as cone is cut inside, here the surface area will be equal to lateral surface area of cone, let it be as some S2, plus this we have the circle at the top, that is surface area of the circular portion of cylinder, let it be as S3. Here S1 will be equal to lateral surface area of cylinder, that is 2 pi RH, which is equal to 2 times 22 by 7 times R is 0.7 times, here the height is 2.4, 7 goes in 0.7, 0.1 times, that is equal to here, that is equal to 10.56 centimeter square. Now the surface area of cone S2 is equal to pi R L, where L is the slant height here, that is equal to pi R into square root of slant height, we know it as square root of radius plus height square, which is equal to pi value is 22 by 7 times R value is 0.7 times R square is 0.7 whole square plus H square is 2.4 whole square, which is equal to, here 7 goes in 0.7, 0.1 times, So 22 times 0.1 is 2.2 times. Square root of 0.7 whole square plus 2.4 whole square is 2.5, which is equal to 2.2 times 2.5 is 5.5 centimeter square. And now the surface area of circular portion is S3 is equal to pi r square, which is equal to pi value is 22 by 7 into r square is 0.7 into 0.7. 7 goes in 0.7 0.1 times, which is equal to 0.1 times 0.7 times 22 is 1.54 centimeter square. Therefore now the required surface area is equal to S1 plus S2 plus S3, which is equal to 10.56 plus 5.5 plus 1.54, which is equal to 17.6 centimeter square. This is the required answer. Now coming to the ninth question. A wooden article was made by scooping out a hemisphere from each end of the solid cylinder as shown in figure. If the height of the cylinder is 10 centimeters and its base of radius 3.5 centimeters, find the total surface area of the article. Now coming to the solution. Here we have a wooden article which is in the form of cylinder with the two hemispheres driven out from it. So now the surface area of this can be obtained by summing up the surface area of the cylinder, that is laterally, and also the summing of the lateral surface area of the hemispheres. This. So in order to find that, he has given certain data, that is radius of hemisphere, that is r is equal to 3.5 centimeters, and height of cylinder h is equal to 10 centimeters. Now the surface area of cylinder is equal to 2 pi RH, that is equal to 2 times 22 by 7 times 3.5 times 10. Here 3.5 goes in 7 2 times and 2 goes into 1 time, that is equal to 22 times 10 is 210 centimeter square. Now we also get the surface area of hemisphere, that is S2 is equal to, let this cylinder be S1, S2 will be equal to 2 pi r square, which is 2 times 22 by 7 times r square is 3.5 times 3.5. Here 3.5 goes in 7 2 times and 2 goes into 1 time, and the 22 times 3.5 is 77 centimeter square. So here we get the total surface area required is equal to S1 plus 2 times S2, which is 220 plus 2 times 77, that is 220 plus 154, which is 374 centimeter square.